Okay, update on this thing. I cut a couple holes here, and that's to access this timing magnets. There's timing magnets on that rim right there, and I can put all of this into there and take power out at the peaks, or maybe short coils at the peaks, or drive it as a motor coils. I just rewired the whole thing. So I was looking at some of my older videos, and it seems the best way to do it is the coil. There's 6 coils in there, and I put 3 in series, and I get about 7.5 volts in each series bank. I put them together, and I get 15 volts, which is what I want. And so the new wiring is, these are bifilar coils, so there's 4 wires coming out of each, and they go, I run 1/2 the bifilar all the way around, and then I use the other half all the way around, and then I connect them together. And right now I have them shorted out. I have 870 milliamps, which is pretty good, and I'm drawing 110 milliamps at 120 volts. And if I look at what the voltage is, not while it's shorted out, but what the voltage is, it's 15 volts out of here. Now, something interesting is about 12 videos ago or more, I had similar and bifilar coils, all 1/2 of the bifilar coils strung together, and the other half of all the bifilar coils strung together. Let me show you here. I'll try to make this quick. Here's what the draw is with the coils not shorted out and the rotoverter motor just spinning the magnet rotors against all the coils. So this is an unloaded alternator, and it's drawing 80 milliamps at 120 volts. You can see here everything's not connected. Now I'll show you what is very interesting. One moment. Also, I took out the there's 8 coil positions, but I'm only using 6, and I took out the coils that were there. So there's only 3 coils here, and 3 coils down here. Here's what the coils look like. Let's see. Right in the middle of them is a ferrite core. It goes full length. And here's the 2 wires. And here's the 2 wires. So it's a bifilar coil. Interesting also, if you're interested, what the coils are wound with is 8 lengths of 28 gauge wire. I forgot I had done this. Yeah, 28 gauge wire, 8 lengths, and then I take 4 of them and I connect them to another 4 series 80. I'm not sure how many feet this is total. I'll measure it later. So these coils are multi-filer coils in here. It's supposed to cut lens law when you do that. Now, speaking of cutting lens law, now watch this. I have this ammeter in 20 amps AC. Now, there's 1/2 the bifilar. I'm going to short it out. Here's the amp draw. Sorry. Okay. This one and this one are the in and out of the 1/2 of the bifilers. Now look how much the draw goes up. It goes up to 140 milliamps. While I'm shorting it out and making 760 milliamps. Okay, now let's do the other half. Here's the other bifilar half. And I'm shorting this one out. I'm also making the same, 760 milliamps. And it also makes the draw of the rotoverter go up to 140. Now, let's connect the bifilers together so that we essentially have a double wire going through the coils. One moment. Okay, so I've connected the bifilers together. I guess you call it parallel aiding. And now look, I'm making 870 milliamps, making more amperage, and I'm drawing 110 milliamps compared to 140 milliamps. So you can't beat that. More power output when you have less draw to the prime mover. That's why I went back to my old wiring method, because this happens. Also, I did a test on some capacitors. I got a zillion capacitors, all these old oil-filled ones, and the one I tested, I think it was this one, a 20 UF. It doesn't hold a charge. You put 120 volts from the grid in it, you take the power off, and it just sinks. Hector says this capacitor is bad and I should throw it away. So I need to go through all my capacitors and see which ones don't hold a charge. The reason they don't hold a charge might be because there's a bleed resistor inside here. I wouldn't doubt microwave oven ones out of microwaves, they have those lots of times. So, I need to check all my capacitors. So, 870 milliamps is pretty good, really. And I'm going to rewire this and make it a step-down, 10-to-1 step-down transformer and use that instead of this. This steps it down, but it only steps it down 160 volts in the run cap phase. Steps it down to about 44 volts. And with a full wave bridge, it comes to about 40 volts. So this thing is going to be pumping 40 volts into the supercap bank and the batteries when they're in parallel. And if it's ever disconnected, it'll blow out the inverter quick, because the battery kind of works like a filter and limiter of the voltage. But I want to run this on supercaps only. And so ditch the battery, so I want to have the voltage that's coming out not be over 16 volts, so it will blow the inverter. And that's about it. I made the air gap wider also because I was looking at my old videos, especially the one where I looped it and the voltage was going up. And I had a fairly wide air gap. And so I went with a wider air gap also. So I guess that's about it. I'm going to make another one of these. Another transformer of these. And that's about it. So thanks for watching.